due to the fact that you can have any number of carbons linked together in a chain, and those chains can take on very different shapes and sizes and they all will have very different properties. There's millions upon millions of organic molecules that we know of now today. And every day there are new organic compounds being synthesized. And in order for science to advance, we needed some universal way to name and identify organic compounds. And this is a problem we've known about for a very long time. In 1892, a group of scientists from all of the countries of the world got together and developed a system of naming for organic compounds. They wanted a system that would require the minimum amount of memorization, but be flexible enough to name any organic compound, no matter how complex it would become. This group of chemists became called the International Union of Pure and Applied Chemistry, or IUPAC. And the system they developed for naming organic compounds has become known as the IUPAC rules. And it's the accepted method for naming organic compounds around the world. Any name that's generated by these rules are known as IUPAC names or systematic names. The basic principle to the IUPAC naming system is that you find the longest chain of carbons and then number that chain to give the locations of any side chains. And there are 4 rules that govern this process. There's a 5th one I'm putting in so that you have the least amount you have to memorize, but it's really just a syntax thing. So, rule number 1. Find the longest continuous chain of carbon atoms and use the name of this chain as the basis for the name of the compound. So here we have an organic compound. 1, 2, 3, 4, 5, 6, 7 seems to be the longest chain I can get in both directions. The longest chain is very rarely drawn as a straight line, so you need to look a little carefully to find it. The groups that attach to the main chain are called substituents because they have substituted a hydrogen. Now, for the organic compound here, there are 2 different colored lines. The yellow line represents 7 carbons, but so does the green line. So I have 2 chains of equal length. You want to use the longest chain that has the most number of substituents. So the yellow line contains the most substituents, so that's the chain we're going to follow. Our next step in naming an organic compound is to number the chain beginning with the carbon at the end nearest a substitute. And this is because we want the substitutes to occur at the lowest numbers possible. So if I start up here with this being 1, because that would be logically, most of you would probably start at the top and just number down. If this is carbon 1, my first substitute begins at carbon 3. If I change that, if I instead start at carbon number 7, or what we would have said 7, we say this is number 1 now, following this blue. The first substitute begins at carbon 2. 2 is less than 3, so the blue numbers are what we will follow. So we number the carbons so that we can give the location of each substituent group. So I have 3 substituent groups that are identical, CH3, CH3, CH3. Those are all 1 carbon and 1 is meth, so we call those a methyl group. And that methyl group, those methyl groups occur at carbons 2, 4, and 5. And how many methyls do we have? Well, more than 1, so we need to specify how many methyl groups we have. 1, 2, 3. Abbreviation for 3 is tri. So this is 2, 4, 5 trimethyl. On carbon 3, there's an ethyl group. 2 carbons is ethyl. Which takes us to the 4th step. When 2 or more substituent groups are present, list them alphabetically with the carbon number they are attached to. So we've already done that in the previous slide. If 2 or more of the same subsequent groups are present, use prefixes to denote how many there are. So again, we're good. We've got that. So 2, 4, 5 is the location of a methyl group because we have 3 of them. 3 is an location of an ethyl group. And the last thing we need to do is just simply state what organic or what chain we have here. We have 7 carbons, so the prefix for 7 is hept. And when you have all single bonds, that's an alkane, so it's going to be a heptane. The main chain name goes last. I'll say that 3 times fast. Main chain name goes last. Then put the substituent groups in alphabetical order. E comes before T, so 3-ethyl, 2,4,5-trimethyl heptane is the name of this organic compound. Lastly, if a functional group is present on the main chain, use the correct suffix by replacing the last E in alkane, alkene, or alkyne with the correct suffix for whatever you're dealing with. So if a hydroxyl group is present, replace the last E, like say you have propane, but one of these hydrogens has is substituted instead with a hydroxyl group. Now it's no longer propane, it'd be propanol. And if you were to note the location of that, if it's anything other than 1, so for example, this hydroxyl group comes off on carbon 1, this is carbon 2, carbon 3, you do not have to say 1-propanol, but you could, and it would be just as right. However, if the hydroxyl group came off of carbon 2, you would say 2-propanol. If you have 2 hydroxyl groups off of the main chain, this now becomes 1,3-propanediol or 1,3-dipropanol. Both would be acceptable. Use the prefix before the suffix to denote that you have 2 alcohol groups. If you have propane and instead you end up with an aldehyde, then propane becomes propanal. If you have a ketone, then propane becomes propanone. Well, you get the gist. If you make an acid out of propane, it becomes propanoic acid. Propanoic acid. And lastly, or almost lastly, if propane has an amine group, it becomes propylamine. Now I know there are 2 functional groups I haven't gone over yet. They are the esters and the ethers. With an ether, you have 2 carbon chains. So carbon chain number 1, carbon chain number 2, attached by an oxygen. And you name each carbon chain separately. So even if it has substituent groups, you would name those. And you would name the substituent groups and the name of carbon chain 2, and then end with the word ether. So for example, here I have a methyl group and an ethyl group, so this is methyl, ethyl, ether, although this should be alphabetical, so it should say ethyl, methyl, ether. With esters, which are made from a carbonic acid and an alcohol, you name the carbonic acid, then the alcohol, and then follow with the word ester. So this would be proponic acid, so we call it proponate. The alcohol would be ethyl alcohol or ethanol, and so we call it ethyl alcohol. So propanate ethyl ether. It looks and sounds confusing. Don't worry, it will not be that bad. You get used to it after a while. It just takes a little bit of practice.